Something in our galaxy has been sending a radio signal every 22 minutes like clockwork, and when astronomers traced it back through archival data, it had already been doing it for at least 35 years without anyone noticing. No known object in physics should be able to pulse this slowly with this kind of regularity. And it is not alone. The object is designated Gleam X J162759.5-523504.3. Discovered in 2022 by a team led by Natasha Hurley-Walker at the Curtin University node of the International Centre for Radio Astronomy Research in Australia, using the Murchison Wide Field Array. The signal pulses every 18.118 minutes, not 22, with each pulse lasting between 30 and 60 seconds and releasing an enormous amount of radio energy. When the team searched archival data, they found the source had been active between January and March 2018, then went quiet. In 2024, Hurley-Walker's team announced a second object, Gleam X J0704-37, pulsing every 2.9 hours, also discovered with the Murchison Wide Field Array, and separate teams have found additional long-period radio transients, including GPM J1839-10, reported in 2023 in Nature by a team led by Natasha Hurley-Walker. This one pulses every 21 minutes, close to the figure in the title, and crucially, archival data traces it back to at least 1988. That means it has been pulsing regularly for over 35 years. GPM J1839-10 is the most extraordinary of these objects precisely because of its longevity. It has been transmitting through data going back decades, hidden in observations nobody had examined for this kind of signal. So what are these things? The leading class of explanation involves neutron stars, the ultra-dense collapsed cores of massive stars that have ended their lives in supernova explosions. A typical neutron star can be as massive as 1.4 solar masses compressed into a sphere roughly 20 kilometers across. Pulsars are rapidly rotating neutron stars that emit beams of radio waves from their magnetic poles. As the star spins, the beam sweeps past Earth like a cosmic lighthouse, producing regular pulses. Most pulsars spin very fast, some hundreds of times per second. The slowest known pulsars before these discoveries pulsed every few seconds. A neutron star pulsing every 18 minutes or 21 minutes is a profound problem. Standard pulsar emission theory says a neutron star slows down over time as it loses rotational energy. When it slows past a certain threshold, called the death line, its magnetic field can no longer accelerate particles efficiently enough to produce radio emission. The death line predicts that a neutron star rotating this slowly should be radio silent. It should be dead. Yet GPM J1839-10 is pulsing. One possibility is that these are ultra-long period magnetars, neutron stars with extraordinarily powerful magnetic fields, orders of magnitude stronger than ordinary pulsars. In theory, a magnetar's extreme magnetic energy could power radio emission even when the rotation is too slow for conventional pulsar mechanisms. Magnetars are known to produce powerful bursts, and their magnetic energy dissipates over time in ways that could produce unusual emission patterns. But a magnetar active for over 35 years, at this regularity, is difficult to explain with existing magnetar models. Another proposal involves white dwarfs, the dense remnants of stars like our Sun that have shed their outer layers. A white dwarf is far less dense than a neutron star but can still have significant magnetic fields and rotation. Some models suggest a highly magnetized white dwarf could produce pulsed radio emission. If these long-period objects are white dwarfs rather than neutron stars, the emission mechanism becomes more physically plausible. But white dwarfs producing coherent radio pulses at this intensity have never been confirmed observationally before. A third possibility is that we are seeing an entirely new class of compact object that existing theory has not fully described, something between a neutron star and a white dwarf, or a neutron star in a physical regime not previously observed. The Murchison Wide Field Array and the new Meerkat telescope in South Africa are now systematically searching for more of these objects. Every new discovery narrows the theory space and makes the explanation clearer, or stranger. What we know is that something in our galaxy has been pulsing for decades, possibly for far longer, and we only just noticed because nobody was looking for signals this slow. Follow for more on the mysteries that radio telescopes are pulling out of the galactic background. And tell me, a signal pulsing with clockwork regularity for over 35 years from an unknown object in our galaxy. What is your first instinct about what it is?